Welcome back to our series on applied regression analysis. I'm Mark Ledbetter. This is lecture video 32. We are in chapter 9, part 4. Last time we talked about the multiple partial f-test, and we wanted to add more than one variable at a time into a model that already had variables in it. Say we wanted to add k variables into a model that already had p variables in it. Okay, and our test statistic was this f conditional, so it was the f of x1 star to xk star given x1 to xp, and we said that it was the sum of squares of x1 to xk given, x1 star to xk star given the x1 to xp over the degrees of freedom, how many variables there are, over the MSE with all variables in it. So the MSE of x1 to xp, x1 star to xk star on the bottom. And we get that from the model, the full model. And I showed you that the other way to do this is the divided by k is the SS of x1, x2, x1 up to xp, x1 star up to xk star minus SS of x1 up to xp. So you can take that subtraction as well if you have two different ANOVA tables. Okay, and the F statistic had the degrees of freedom here under the null, and so our rejection region is F calculated or F observed. Sometimes I like to say F observed because we calculate it from the observations, is greater than F of K, numerator degrees of freedom, N minus P minus K minus 1 with 1 minus alpha. Okay? Now, this time we're going to talk about strategies for using these partial f-tests. Okay? Because as you can see, last time I showed you that while we would add x2 to the model, if we tried to add x2 and x3 together, it said no, and so we failed to reject the null, so neither one of them went into the model. And so we need these strategies so we know, so that we end up with a model that has the best fit and the best predictive ability for y, our dependent variable. Okay, so there's two strategies, and the first is that we variables are added in order test. So in other words, sequential, and this is called type 1 sums of square test. And then variables added last test, that's called type 3 type 3 sums of squares. So type 1 sums of squares and type 3 sums of squares. Okay, and SAS, we're using Sas Output. That's what the book uses. We'll see what we can do in R later next week. So the Sas Output here. So this is the value. So I included the table 8.1. This is the actual data values that we have here. Okay, and then this Sas Output. Let's see what we have. We have the source, we have model, error, corrected total, or y, or total. As you remember from last time, here's our degrees of freedom. So this has 693, and so I'm going to say that this has x1, x2, and x3. I remember that from last time, and this is 195.19 basically. And we have our mean square 24.4, right? So it was our MSE that we saw, and the F value here, and so we have our, okay, so now we have down here type 1 SS, okay, and here we have type 3 SS, okay, so that's, and then we have our parameter estimates down here, intercept, height, age squared. All right, and the standard error. So this printout has a lot of information here, and the authors have marked with different quantities as we go through. So we'll need to refer back to this. So it's again, it's as I guessed, it's for the model with the full model weight regressed with the intercept, height, age, and age squared. And so it says these results were computed using centered predictor. Centering is subtracting the mean of the variable. And this procedure gives a better computational accuracy when estimating higher order terms. So this is important to know that this is something for your bag of tricks when you're actually out there applying regression. You want to remember this. Center your variables, subtract the mean from it, and this will give you better computational accuracy, so you'll have less error, computational error, because computer error is actually a big thing. And when you're doing something that's really important, you want to minimize that. So this is a way to do that. So there's the variables added in order method. So here's the procedure. An order of adding variables is specified. So you have to determine which ones to add first. Now, we're going to, in chapter 16, I believe it is, we're going to learn how to add variables one at a time, and there's some methods. We have adding one forward selection. There's adding using backward selection to do this. There's stepwise selection, but this is a procedure that requires you to put the variables in an order, specify. So this is actually a drawback of this procedure that both of these, that you have to decide what order you want to test the variables in. Okay, so if you choose wrong or poorly, you can end up with a model that's not as good. So you're going to test the significance of the first variable. Okay, and so if it's not significant, you may stop, or you may continue and see, but usually you stop there. And so then once you have the first variable in the model, you're going to test the significance of adding the second variable, given that the first variable is already in the model. And then we take the third variable and we test the significance of adding the third variable, given that the first and second variables are already in the model, and we keep doing that. That's why the ... is for 5. Now, the variables added last method. You have an initial model with 2 or more variables already in it, specified. And so you're going to test the significance of each variable as if it were the last variable to enter the model. Okay? So it says for k variable model, k variables added last test are performed. Okay. So let's see how these work. For example, let's consider the variables added in order test. Suppose we want to perform the test in the order of height, age, and age squared. And if you remember earlier, we already looked at the individual models of these back in chapter 8. So if you look back in chapter 8, you'll see height by itself, age by itself, and age squared. So we'll see, we can tell by the p-values of the slopes of each of those which one is the best individually, right? So we could cheat and do it that way. All right. So we're going to start with this model. Weight is beta naught plus beta 1 times x1, or height, plus epsilon. And so the overall regression f-test is beta 1 is equal to 0. And that's used to test the significance of height. Now the second model would be the weight is regressed by the intercept, beta naught, plus beta 1 times height, plus beta 2 times age, plus epsilon. And here we would use the partial f-test, age given height, to test for beta 2 is equal to 0. And then the third model, and final model in this case, would be the full model with height, age, and age squared in it. And again, we use this f-test, this partial f-test, age squared given height and age in the model, to test whether the third intercept, beta 3, is equal to 0. And this result is provided in the center C, or type 1 section of the previous SAS. So let's look at that. We did see this in our previous emails and videos. Hope this is not an email. Okay, so type 1 here. And it said C. So C, the reason it says C is because that's where the p-values are. So let's see if I can get this about right. So we've got height here, and we see the type 1 SS. Oops, and I can't draw a straight line unless I really concentrate. Okay, and so we had an F value of 24.14, and the P value was 0.0012. So that's significant. We definitely want that one in there. Okay, and then we test age given that height is already in the model. And so the additional sums of squares is 103.9 added to the 588. Okay, and the p-value there is 0.073. It's less than 0.1, so I'd have to look at some other measures, but it's pretty certain that I would include that in the model because it's going to add significantly to the prediction ability. But then we look at age squared given that height and age are already in the model, and the p-value is, as we saw before, 0.29, actually 0.294, so very small. Okay. So that was adding one at a time. Let's get back to where we were. Okay. So the results there. So we see that we would end up with this test, we would end up with the model. The model that we would select is WGT equals beta naught plus beta 1 HGT plus beta 2 age plus epsilon. That would be our selected model using that method. Okay, so now let's look at the variable added last model. We first consider the full model with all three variables in it. Okay, and to contribute to test the contribution of of height, we compare the full model to the model without height. So we have a reduced model that just has age and age squared. And so the partial F test here for height given age and age squared is used to test whether beta 1 is equal to 0. And then we do the same thing with age. We'll consider this full model up here, and we'll compare it with this reduced model here that doesn't have age, but it does have age squared. And this is used to test for beta 2 equals 0. And finally, we'll compare the full model again to the model with height and age, but not age squared. Okay? And so we're going to compare those. And so let's look at, well, I don't think we're ready to. Sorry about scrolling so much. So it says the partial F test is used, all right, so the results for the variable added last method is provided in the section D for type 3. So let's look at that. And so D, so I'm going to erase my red lines here for C. And now let's look at D. And so I have height. Okay. And then age. And then age. Okay. And so really we're going to be comparing, so this is the full model up here. So this is the full model, is A. Okay. So we can use the values from there to calculate the quantities we need for the F test. So height, if we take the this and we remove height, the difference is going to be this here. Okay. And so we have a p-value, F statistic of 6.83 and a p-value of 0.0310. And so that is less than 0.05. So we would say that we would want to include height. And now the next thing we do is we compare this full model again to this what is by removing height or by removing age, the difference between that model and this full model up there, 693, is 101. And so we get a F score of 4.17, and that is pretty close. It's different, and it should be, but it is different, but it is close to the one up ahead, above. So 0.0753. So again, between 0.5 or 0.05 and 0.1, again, I would put it in the model unless I saw something that would tell me not to. And then we do the same thing, and the difference is only 0.4. And you notice that this and this are the same, right? Because it was the third variable in this, so it was added last. Because it was added last, these two values are going to be the same, because removing it from the variables added last method, that means you're comparing it to the previous, and that's what this last one is doing. So those two end up being the same. They're the only ones that end up being the same, as you can tell, between the two methods. And so we get exactly the same result, and we don't want to add that one in the model. So let's go back. And it says an important difference between the tables for variables added in order test and variables added last test is that the sum of squares for variables added in order do add up to the overall sums of square error, while the sums of squares for the variable added last do not. So do not try to add these up. Let's take a quick look. Let's take a quick look. If I have these, they're way less than this. I mean, that's less than 300 here. And we know that, let's see, so that's 690, yeah. So this is nowhere close to this, to the 693. But this is, adding those together, does give us the 693. All right, so that's what it's saying there. So be careful. Don't try to add when you're using the variables added last method. It doesn't work. You have to be more convoluted to get the answers you want. You have to really think it through and think about what is there. Okay, so choice between the two strategies. Okay, when we have no good idea about which variables would contribute more to the prediction of y, we should use the variable added last method. Remember, I just before said the disadvantage of using this method is that you have to determine the order, and if you don't know that, then you can end up with a bad test. But for this one, you're going to remove one of those each time. You're going to remove each one and compare each one individually. So it's going to give you the right answer, whereas if you don't know which one contributes more and which one contributes less, going the variables added first method could give you a bad model or poorer model than you should have, not the optimal model. Okay? So the variables added last method is preferable when we don't have an idea about which variables contribute more. So it says occasionally, and that is true, occasionally we have a good idea about the importance of variables, so we can order the predictors in advance, and then we can use the add and order method. Okay? So if we want to include the corresponding first order term, x1, x2, when we find an interaction, so for example, we may want to include the corresponding first order term, x1, x2, when we find an interaction term significant. So this is called interaction between x1 and x2, and we haven't talked about that yet, I don't think. Okay, so let's look at these tables for the variables added last regression models. So model number 1, we have height, age squared, and so the SSE here, so this is the SSE. Before we've been looking at SSR, so this is giving us the SSE with the full model. And then this is missing height, here's our SSE. Missing age, here's our SSE. Missing age squared, here's our SSE. And then, let's see. So what's the difference? Height, age squared, and E. Oh, I'm sorry. So here we missed the, I forgot that we were missing the intercept. So we tested for the intercept here. I forgot that we were doing that. All right. So you want the smallest SSE, but if you'll notice, the difference between these last two is extremely small. And so it really isn't worth, I think we talked about this in Chapter 8, it really isn't worth the additional variable and complexity to get that little bit of reduction of SSE. Okay? So here's the variables added in order regression. And so with none of them in there, of course, we've got this huge SSE. And then with just the intercept, it's down to 888. Okay? And then with height only, 299. And then we add age, and we get 194 point. Notice that the last two variables here, or the last two values there, are the same as the last two values up here. Okay? And so, again, we see that we've reduced significantly between 299 and 195, but almost no reduction to add age squared in there. Okay. And so here are some computations that we could do. And so to get, for the intercept, to get this 24, where is it? Yeah, 24,421. How did we get that? We took SSE1 here, and we subtracted SSE5, which is here. Okay? And so that gives us, this is added last, okay? So that would give us for the intercept there. And, all right. And so then for added in order, we take 6 minus 7. So here's 6, and we subtract 7 from it, and we get 47 for that one. All right, so this is how we get the values. Let's see, so 224, all right, yep. And then for beta 1, we take SSE2 from 5. So here's, let me clean up. Here's 2, and here's 5. And so that would give us the difference there. Okay, 166. And this is what's in our table. So let's look back in our output. Okay. And we don't have some of this, but we do have, so we don't have the intercept information up in here, but that's okay. We usually don't look at it that way, but we could. And so they're being thorough. And so here's the 166. How did we get that? So let's come back down to here. And it says to get the 166, we took SSE2 and SSE5. So SSE2 has age and age squared only in it, and the intercept. And 5 has the full model. So when we subtract those two, that's how we get the 166. And then to get for age, we take 3 and 5. So now, let me clean this up. We take 3, subtract 5, and that gives us the 101. And then we take 4 minus 5 to get the 0.24. And then for the order in added in order ones, I'm not really worried about the top one since we didn't have that in the printout, or the top two. But then to get the 588, we took 7 and subtracted 8 from it. Okay. And then to get the 103, we take 8, which is here, and we subtract 4. Notice that 4 and 5 are repeated down here. So we subtract 4. So which one? 7 and 4. 7 and 8, and then 8 and 4. So here's 8, Here's 4. We subtract those to get this, and we subtract 4 and 5 to get this, just like we did here. Okay, so that's how those calculations, that's how you get those numbers. So take a look at that. Make sure that you understand how these numbers are gotten and that it makes sense to you, because the homework will test your ability to think through these. Okay? So please remember to scan your lecture notes before midnight, the date listed in the course calendar. Update your formula sheet. Come to virtual office hours if you have questions. If you can't make it, email me, but make sure you send me a picture of the problem and a picture of your work so I can help you by email. Please take care of yourself and stay safe, and we will see you next time.